How's it going, aspiring elementary school scientists? I'm here with the Science Honor Society up here at the high school. I'm representative from it. My name is Aidan, and today I'll be showing you the science behind the mechanism that we recently taught you in school about this little electromagnet called the homopolar motor. So yeah, as you saw, when you attach a wire over a battery with some magnets on the bottom of it, the wire will spin around in an interesting fashion. So the way the homopolar motor works is that the battery is in the middle. There's about 3 or 4 magnets on the bottom, and there's a wire which I decided to put in a bit of a heart shape that goes around it, and it spins. So first I'll explain how a battery works. So for the battery to work, for this whole motor to work, there needs to be a current in the wire, a current from the positive to the negative sides of the battery. So the battery has 2 sides, the positive terminal and the negative terminal. The negative terminal is where these small particles that have negative charges, hence the negative side of the battery, these small particles called electrons. And basically these small electrons, they flow through the wire up here in this little arrow of a current. They flow upwards through the wire into the positive side. So basically every time you see a wire, a circuit, anything like a light bulb turning on, this is happening every single time in the wire. There's always a flow of these small little electrons that cause basically electricity. So yeah, so basically as these little electrons move throughout the wire into the positive side of the battery, there's a small interaction that's caused within the wire that causes a small magnetic field. And I'm sure you understand what magnets are. They attract each other and repel each other. And this is all because of small attractions between small particles and stuff. And yeah, so this little occurrence is happening in the wire. So basically, whenever there's a movement of these electrons, there's a small counterclockwise rotation around the wire, which basically creates a small magnetic field where I guess positive particles will be attracted to the negative particles, which in this case are the electrons. Positively charged and negatively charged, the opposites will always attract. So now when this small magnetic field comes into contact with the large magnetic field, which is produced by this mass of magnets down here, basically the magnetic field goes all around this battery. When the 2 magnetic fields interact, there will be a force which is exerted on the wire. A force that basically like a small basically like force that will exert some movement on the wire. So this the force, they will push the battery around. It'll push the wire around the battery, and as long as there's still current moving throughout the wire, and the 2 magnetic fields are still, I guess, functioning and working, there will always be movement. So sometimes if you build one of these things and you see let's say like the wire loses contact with one of the magnets, or maybe the top part of your function, your creation, like the top of your spiral or heart, whatever it is, comes off the top little positive terminal of the battery, it'll stop spinning. And basically because there's no current of these little electrons moving through the wire to create the magnetic field. And yeah, so basically those are that's how the homopolar motor works, the thing we showed you in class. It's basically just motion caused by 2 magnetic fields that are interacting with each other and causing a magnetic force, which in turn moves the wire around the battery in a pretty interesting way. All right, so here we're going to show you, I guess, demonstrate again what you were shown in class. So here you have your 3 or 4 batteries. There's no real amount, but anywhere upwards than 3 you can attach to the bottom of the battery on the negative side, like I taught you earlier. And yeah, we have a few here. So basically, whatever wire you have, you can make any sort of shape. You can make a spiral if you want. You can make a heart-ish shape, just as long as the shape is balanced, like it has the ability to balance on top of the battery and it touches the magnet. Hopefully the current will flow and the homopolar motor will work as intended. So now let me just test this one out really fast. And then just like that, it begins to spin. And remember, like as I said, this is because there's a current of electrons or negative particles flowing from the negative terminal to the positive terminal of the battery, and the two magnetic fields of the negative particles in the current and the magnet are basically pushing around the wire in this circular little fashion here. So here, I'll just set up another one right now. This one's more of a spiral shape. Let's see how this one does. Looks like that one doesn't really move that well, but try this other one. Yeah, sometimes it's a little difficult because sometimes the wire can get caught on the battery. Yeah, you see here, that's a good one there. Let me start this one up again. And yeah, just gotta make sure, try not to have the wire touch the battery too much, because then it could get caught pretty easily on the magnets. Like it could be hard for it to move. Some of these other shapes are a little trial and error here. But yeah, it's pretty interesting. You can attach things to the top of the wire, like we have here, for example, a heart that one of us attached. This one, it doesn't really work that well, but you can try, and you can make things spin around in a pretty interesting way. And yeah, and if you get it just right for a long amount of time, your model can balance pretty well and spin pretty well for a long time. And yeah, it's pretty interesting. You have your own little electrical and magnetic motor, basically, right here, with only a little battery, a little wire, and a few small magnets.